I want the area of the base. So that 15 centimeters is the height, 16 centimeters is the width. The area of that base is just the area of the triangle. So the base equals 1/2 the small b times the height. So 1/2 16 times 15, right? I get that from over here, 1/2 base times height. Okay, so if you want to take notes on this, that'd be fantastic. What is 1/2 times 16 times 15? Anybody do that calculation for me?
120.
120, absolutely. Are you kidding me? Gosh. All right, 120. And since that's area, that's centimeters squared, right? The height of the whole shape is this part. So the height of the whole shape is this part. That's 20. And then the perimeter of the base is this part. So the perimeter of the base is 17 plus 17 plus 16, right? So 20 is the height of the whole shape, where 15 is only the height of the base. And then the perimeter is the perimeter around the base. So 17 plus 17 plus 16 is what?
Wait, how'd you get 20 though?
20 for the height of the whole shape?
Yeah.
Because the height of the shape is not the height of the base. The height of the base is that 15. So think about it this way. If this shaded part here is the base, that's what it sits on. So if it's standing up like a house, like say this is a weird shaped house, it's sitting on its triangular base and it's 20 centimeters tall. So there's two heights. The height of the base equals 15, and the height of the shape is 20. And it's confusing. Very confusing sometimes. So then I want to find the surface area of this whole shape. So I need to do the surface area, height times perimeter plus 2 bases. Height times perimeter plus 2 bases. So the height times the perimeter, and that's going to be the shape height, not the base height, plus 2 bases. So my height is 20. My perimeter is 50. And the 2 bases are 2 times 120. Triangular prisms are tough. They do all kinds of weird things, right? Notice that the area of the base is a capital B. So when we do all of this, we get 100 plus 240, or 340. So blank one. The height was, oh, you're right. The height is 20. I just wrote a 2. So that's 1,000. So that's 1240. That sounds better. Thanks for that catch. How do we feel about that? Did I do anything else crazy?
I don't think so.
Okay, let's look at the next one. If I do something crazy, let me know. Find the volume of the triangular prism. So we've got all of the same stuff, which is convenient, right? 17, 15, 16, that's the same picture, 17, 15, 16, and 20 and 20. So our area of the base is still 120, right? The area of this base is 1/2 the base times the height, so that's 120. The height of the shape is still 20, because if it's sitting on its base, how tall is it? Now I need to find the volume. So volume is just base times height. Always reference that formula sheet. Volume equals the area of the base times the height. So that's going to be 120 times 20. So what is 120 times 20? So now we've got a different shape. We had one that had a base height of 15. Now we've got a base height of 8. Give the volume and surface area of the triangular prism. So volume was base times height, and surface area, right? Surface area was HP plus 2B. So we need to find the base. So that's this part, right? So the base equals 1/2 the small b. So the 12 is the small b. And the height here is the 8. So the area of that triangle at the base is 1/2 times 12 times 8. So 1/2 times 12 times 8. Did anybody get 48? Check my answers because you know sometimes I go crazy. Oh.
Yeah.
Yeah, okay. And then how tall is the figure when it's sitting on its base? That's going to be the 20 again. The perimeter is a problem though. So the perimeter is this distance all the way around, and we don't know these numbers, right? So if I draw that triangle over here, it's going to be isosceles. If this whole thing is 12, then each of these are 6, and the height is 8, and that's a right angle. So if I've got legs of 6 and 8, how do I find that diagonal? Can I do Pythagorean theorem? A squared plus B squared equals C squared, where my legs of 6 and 8 are A and B. So 6 squared plus 8 squared equals C squared. So that's going to be 36 plus 64 equals C squared, or 100 equals C squared, or C equals 10. So see how triangles get super complicated? If the hypotenuse of that isosceles triangle is 10, or those two base sides, congruent sides are 10, then the perimeter all the way around is 10 plus 12 plus 10. So that's 32. The perimeter is the perimeter around the base. So now we can substitute and find the volume, right? Volume is going to be the base, which we got 48, times the height of the whole shape, which is 20. So 48 times 20. Michael, we are in Friday's quiz on surface area, or on triangular prisms. I'm sorry, honey. So if you go into the day 1, which was Friday, of surface area and volume, you'll find triangular prisms. So you want to be here, January 15th, triangular prisms. So 48 times 20, oops. $48 times 20 gives me what?
960.
960. 960. And then volume is going to be the height of the whole shape times the perimeter, which we found was 32, plus 2 times the base. So 20 times 32 is 640 and 96. It's going to be 736. And that's going to be centimeters squared. Oh, wait, I put that in the wrong spot. So our 960 goes here and 736 goes here. The surface area is 736 and the area was 960, or the volume was 960. Be careful with triangular prisms. There's a lot of nuttiness that happens with them. Any questions on that one? Michael, did you find where we are? Question number 4, we're only given the base picture, right? The height of a triangular prism is 7. So if I kind of draw this out, the height is going to be 7. The base is an equilateral triangle with sides of 5. Find the volume of the prism. So if I know that the side is 5, and I know that make the base and the height make a right triangle, then this is 2.5 and 2.5. How do I find the height of that base? I've got a new triangle, 5, 2.5, and I want to know what B is. How do I use Pythagorean theorem there? Can I still substitute? I've got A, B, and C. So 2.5 plus B squared equals 5 squared, 2.5 squared. So B squared equals 5 squared minus 2.5 squared. So what is 5 squared minus 2.5 squared? Should be a little bit less than 20. I got 18.75. So all we're doing is finding that other leg. We're using Pythagorean theorem. We're recognizing that this is a right triangle. And B equals the square root of 18.75. Almost put 25. 4.3. 4.3 is the height of the base. So to find the area of the base, I've now got to do 1/2 base times height. So 1/2 the base, which is 5, times the height, which we just calculated to be 4.3. Remember, we can find the height of an equilateral triangle by dividing it into 2 right triangles. If this base is 5, then half of that is 2.5. So what is 1/2 times 5 times 4.3?
I got 10.75.
That's what I got too. Anybody else get that? 10.75?
Yeah.
Sweet. Then the height of the triangular prism is 7. Remember, that's different than the height of the base. So then the volume is just base times height. So volume is the big B times the height. So multiply those two things together and you should get like maybe 73. 10.75 times 7. 75.25. And since that's volume, that's going to be centimeters cubed. Mm-hmm. It is. I was just looking at that. I'm like, wait, why are there 4 blanks? Because there was one at the top. So 4.3 and then 10.75 and then 7 and then 75.25. I think are what your blanks should be. And that is it. So would somebody submit that for me? And let's see if there's any kind of craziness that we did, because I did not check this answer key.
The perimeter is wrong in the surface area.
The perimeter is wrong.
And the surface area.
10, 10, and 12. So question 3, perimeter and surface area. I'll check those and see if I can modify the answer key. And then surface area, 736. Did we do anything wrong? Because it looks like this is right. 6, 6, 8, 10. 10 plus 10 plus 12 should be 32. And then surface area, height is 20 times perimeter, which is 32 plus 2 bases. 20 times 32 plus 2 times 48. 736. Okay. Were those the only 2, Nasia?
Yes.
Okay. Sweet. The next thing I would like for you guys to do is jump over to today's folder. Any other questions on triangular prisms? Cylinders and spheres are a little more straightforward. That's what we're going to talk about today. Maybe. I don't need you. It closed my Schoology. Let me stop sharing for a minute. All right. So I'm sure you guys got there faster to today's lesson. We already did the warm-up. I'll post the videos here. There'll be 3 of them today, I guess. There is a link to this if you'd like to practice some more. There's definitely some good practice in that review. But where I really want you to go right now is cylinders and spheres. And I'll put that maybe in the chat. Will somebody put something in the chat? Anything, just so that it pops up on my screen? Beautiful. So if you need it, there's the Pear Deck link. You are also welcome to click on this slides link down here. If you're frustrated that the Pear Decks are not coming to you and you don't have those notes, on every single Pear Deck, there's a link to slides underneath it. So you can 100% do that as well, okay? So this is where I want to be. If you're in Pear Deck, the formula sheet is not going to link. So I put it here, but if you're in the slides, you definitely have access to the formula sheet. You should also always already have that open. These are our shapes for today, cylinders and spheres. We don't have any weird perimeters. We don't have any weird slant heights. Cylinders and spheres are a whole lot easier. So if we go to this very first one, What are we talking about? If H is 10 and R is 5, then calculate the volume. So what math do I need to do? What math do I need to do for volume? On a piece of paper, on your pear deck, on something. Let's do that. So pi, we know the radius is 5. So 5 squared and then 10. You can always label that in your picture. Give yourself a visual. So what is pi times 25 times 10? We could leave it as 250 pi, or we could multiply by 3.14. Did anybody get 785?
Yes.
Awesome. And that's going to be units cubed, right? I don't know what the units are. They didn't tell me, but it's going to be units cubed. So then lateral area, remember lateral area is the space around, right? So when we're talking about lateral area, we're talking about like the soup can label, not the whole thing, right? So this is like the label. And LA and labels start the same, so that's kind of easy to remember. 2 pi r h, so we just substitute 5 times 10. So I can multiply all of those numbers super easily. That's just going to be 100 pi, or 314 units squared. Easy enough? I love cylinders. So straightforward. Notice that the surface area has the lateral area plus the top and the bottom, right? So that's 2 areas. If this was an open can like my coffee cup, then I would want the lateral area plus just 1 base. But here it's a whole soup can. So this is a can, top and bottom. So I'm just going to do 2 times pi times the radius. That's my top and bottom. And then plus that lateral area, which I already solved for. So I'm just going to substitute that in, right? That lateral area we already solved for up here. So I can just plug in that 314. So if I do 2 times 25, this is going to be 50 pi plus 314. So 50 pi plus 314. Oops. Did you get 471? Are you guys okay with me just substituting in the lateral area that we got up here in the surface area?
Yeah.
Kind of maybe. If you don't like that, you can always substitute it back in, right? If this was a brand new problem and it was just asking me surface area, I would just substitute it all in and do 2 pi 5 squared plus 2 pi times 5 times 10. That's a 10, right? If it was a brand new problem and I had not already calculated lateral area, I would do that. Questions on cylinders? All right, let's talk basketball. So there are 4 different size basketballs, right? And the NBA uses this one. I think the WNBA actually uses this one, right? So fun fact. We've got some fractions here. Don't let the fractions scare you with spheres, okay? What's the volume of the largest basketball? So if I want the volume of this largest basketball, I'm going to do 4/3 times pi times the radius. Oh, we need to figure out the radius. If circumference equals 2 pi r, and circumference equals 29.5 inches, can I set these two things equal to each other? So 2 pi times the radius equals 29.5. And then divide by 2 pi and divide by 2 pi in order to find r. How do we feel about that algebra? 29.5 divided by 2 divided by 3.14 is what? I feel like I did something weird. Oh, I did. I multiplied, not divided.
14.75.
14.75 when you divide by 2, and then also divide by 5. So we're going to put this whole thing in the calculator. 29.5 divided by 2 gives me 14.75. And then 14.75 divided by pi gives me 4.7 if I round. So sometimes with circles, we're given the circumference or the area, and we have to calculate for that r. So the r here is going to be 4.7, and then we want to cube it. Now I'm going to put, say that again. Yeah, so when I put it in my calculator, I do 29.5. 29.5 divided by 2, and then 14.75 divided by 5. Or you could just put the pi right in here. So yeah, you definitely want, because it's 2 pi r, and we want to get the r by itself, you have to divide by 2 pi. Divide by 2 pi. So then when you put all this in the calculator, 4/3 times pi times 4.7 cubed. So again, just those. You're going to do 4/3 times pi times 4.7 cubed. 34.9. And this is going to be inches cubed because it's volume. Does everybody understand how to find the radius from the circumference so that we can find the volume with the radius? Do I sound weird? Do I have the Terminator voice? It's my internet. As soon as I'm allowed to go back in the building, I'll go back to teaching in the building, so I don't have this problem. If you go to slide 4, what is the surface area of the small basketball? So for surface area, when we look at our formula sheet, 4 pi r squared. 4 pi r squared. That looks weird. Surface area, 4 pi r squared. Well, it is correct. So we're going to do 4 pi r squared. 4 pi. But we need the radius again. So whatever the radius is, squared. We're given the circumference. So circumference equals 2 pi r. And I know this is 25.5. We've got to divide by 2 pi again. So 25.5 divided by 2 pi. Already in your guess mode, you've got this. So 25.5 divided by 2 pi is going to be 4.1. So 4.1. And then you just got to put this in your calculator. 4 times pi times 4.21 squared, because we're finding the surface area. 4 times pi times 4.1 squared. You get a little over 200. You got an answer. You get when you put that in the calculator. And this is inches. This is surface area. So this is inches squared. Yeah. All right. Let's see if we can put it together. Okay. Into something real world. So this is a new concept drawing of what will be or could be a $300 billion international space station. Okay, you know there's an international space station up in space right now where a whole bunch of astronauts from around the world hang out. That one costs $100 billion. This one, if it's allowed to be built, will be 3 times that much, $300 billion. And it's made of a small hemisphere here, so that's half a sphere, and a big hemisphere over here, that's half a sphere, and then a cylinder in the middle. So we've got a small hemisphere, we've got a cylinder, and then we've got a large hemisphere. Hemisphere is just half a sphere, so like half a basketball. What's the volume? So kind of like that cone sitting on top of the cylinder, we've got to find pieces. So the small hemisphere, let's do that first. The small hemisphere has a radius of 50 feet. So the radius here is 50 feet. So if I'm trying to find the volume of the hemisphere, I've got to do 4/3 times pi times that radius, which is 50, cubed, but then I only want half of that because it's a hemisphere, right? So then multiply by half. Put all of this in your calculator and see what you get. 4/3 times pi times 50 squared, or 50 cubed. And then multiply by 1/2. What's the volume of that? Anybody get a number? I got a really big number. 261,660. I'm going to round it to the nearest whole number, which would be 7. And that's feet squared. Feet cubed. Right? Are you with me? Okay. So now I have to find the volume of the cylinder in the middle, right? The volume of the cylinder is going to be pi times the radius, which is that 50, squared times the height. This height here is the length of the cylinder, which is 125 feet. 125. So if you put all that in the calculator, 3.14 times 50 squared, and then times 125, you get something even bigger. 981,250 feet cubed. That's almost 1,000,000 square feet. A big house is like 2,000 or 3,000 square feet. The biggest house I've ever been is 10,000 square feet. That's crazy. More than 1,000,000 square feet in that cylinder. Then we need to use a large hemisphere. So we're going to do the large hemisphere the exact same way we did the small one. So 4/3 pi. This time the radius is 100 feet. And then because it's a hemisphere, we have to divide it in half. Okay. So the only thing that was different here was that radius. Radius of 50 for the small and radius of 100 for the big. So put that in your calculator and see what you get. Make sure you cube it and then divide it by 2. Why are we dividing by 2? Because it's a hemisphere. Do you think there's more volume in that big hemisphere in like that top of the mushroom looking thing, or more volume in the cylinder?
Cylinder?
I would think so too, but do the calculation. Put this into the calculator and see what happens when you add that 100 cubed. Cubing something does create so much more volume. There's more than twice as much area in this mushroom part than in the cylinder here. And then to find the total volume, we'd have to add all 3 of those up. So 2 million plus 981,000 plus 261,000 is going to give us over 3.3 million cubic feet of area or of volume. That's 3.3 million. Or what I really got in my calculator was 3,336,250 feet cubed. No wonder it's going to cost $300 billion, right? Questions on that? When you have a compound shape, you just need to find the volume of each of the pieces and then put it all together. You got a different answer? Where did I go wrong? What did I do wrong? What's different? Oops. Did anybody get a different answer? Remember, we're using pi. So I just put in 3.14. If you got a different answer, you might have used the pi button, which uses all of those numbers after the 3.14. Because we're working with such big numbers, if you push the pi button, you're definitely going to get a different answer. You ready to go to the last slide? Okay. We've got that same International Space Station to replace the current one, but now we're talking about the surface area. So we know the astronauts, when they get there, are going to have 3 million cubic feet of space inside, but how much material is it going to take to build it on the outside? So that's the surface area. That surface area is going to be what we're going to do. So we want the surface area of the sphere, again, divided by 2, because we've got to find only half of it. And the surface area of this bigger one divided by 2. But what are we going to use the surface area for the cylinder, or are we going to use the lateral area? Do we need the circles at the top and the bottom, or do we just need all of the material to make the tube, the soup can label? I think we're just going to use lateral area. So here we need the surface area for this, right? And we need the surface area for this. So we're going to divide both of those by 2 because it's a hemisphere, not a total sphere, right? Hemisphere and hemisphere. And then we're going to use lateral area for the cone, for the cylinder, because all we need is this space around, right? We don't need the top and the bottom. We don't need the top and the bottom. We just need the space around that soup can label. So for the small, we're going to do 4 times pi times that radius of 50 squared divided by 2. And for the large, we're going to do the same thing, 4 pi This time 100 squared divided by 2, right? So I've got the radius and the radius. Then we're going to do the lateral area. So the lateral area of the cone is going to be 2 pi. The radius is just this part, the radius of the small. So that's 50. And then the height here is that 125. The cylinder is laying on its side, so the height is 125. Okay, put those things into your calculator and see what you get. So I got 15,700 feet squared for the small hemisphere. And then 39,250 for the cylinder. Again, that's feet squared, right? And then 4 times pi times 100 squared. Make sure you divide that by 2, right? We only want half of that basketball. We only want half of that sphere. So 62,800. Then we've got to add all of those up. Again, this is surface area, so it's feet squared. So 62800 plus 39250 plus 15,700. How are they going to get over 100,000 square feet of material out into outer space? I don't know. But if you ever wanted to go figure out how to do that problem, you could go work at NASA or SpaceX. All right. Questions on any of that, guys? That was fast and furious, cylinders and spheres. The takeaways from today are hemispheres are half spheres, so you have to divide them by 2. And then sometimes when you've got triangular prisms, you've got to use Pythagorean theorem to find other parts of the triangle, right? What I would like for you to do now is spend the last 10 minutes of class practicing. I'm here for you as a resource, but you've got cylinders and spheres. Just like the rectangular prisms, the cylinders should be super easy, hopefully. So if you open that up, you're going to use the formula sheet, find the volume and the surface area, use 3.14 for pi. Use 3.14 for pi, and then round to the nearest hundredths. So don't use the pi button, use 3.14. Otherwise, your answers aren't going to round quite correctly. And if we have issues with that tomorrow, I'll go back and change the answer key. Okay? So last 8 minutes, do the cylinders and the spheres questions. And if you have a problem, let me know.